Hello, friends. Welcome back to the bench. Thank you very much for joining me. We have a Gigabyte. This is Z890. It's slightly different than the what we usually work on. It's got interesting IOs, but both the PCI Express and memory slots are SMD. They're not through-hole. That's not very common. Those short PCI Expresses are through-holes, but the main one is fully SMD and white. It's kind of different than what I'm used to. We got 1, 2, 3, 4 NVMe's. This is 1851 socket. One of the coils is a little crooked. Not that it matters, but it probably came from factory like that. I don't see any any signs of anyone doing anything to this board. It's pretty serious, pretty powerful board. Um, Now we're gonna use Rework Pro 11110. The 1111 is not released yet, but I fixed the cold start and I finally released Rework TC 131. So if I suggest not doing anything yet, right? Because version 1111 will come with a flasher, so you can if you want to, you can upload the new firmware manually. Just check out the latest master, and that's version 11 or 131. Or just check out the release, the latest release. But as I said, I recommend just waiting. The version 1111 should be out this week, I would think, but we shall see. Now, one modification I have to add to my profile, and that confirms, the problem I already alerted you guys to, is that time dilation problem. So every profile needs to be slightly tweaked, because it might seem, especially when you go by the timer that you see in Rework Pro, everything seems the same, but for some reason the socket doesn't want to release. Well, because the time was different. And I always say that instead of increasing the temperature, I just increase the time. Let it heat up. Don't increase the temperature. The board thickness is 1.9 or 1.85. Yeah, roughly 1.9. So this is a thicker board. Doesn't seem like much, but yeah, it is sufficiently thick. So we shouldn't worry about overheating, but it's gonna take a little longer to release the socket, especially since it's 1851. But the outline is awesome. Well, awesome enough. Yeah, looks like we're on the line everywhere. Mm. Well, now the right side is a little bit shifted. It's a little bit shifted to the right. So we just have to remember that. But the thick board means it should be easy. Meaning, the board is not gonna get damaged, and it's just a matter of time. It's not gonna deform too much. Although that last one we did, it didn't really deform much, even though after the procedure it was flimsy. So sometimes those thinner boards are they are what they are. They just don't like the temperature. Now, could I have done something better? Perhaps. I was thinking if I drop the temperatures and increase the time, that would be better. But even judging by the cups exploding, that's an old cup. Now, you might, because some people cover the cups. I usually don't, even if they're electrolytic cups like this. They should withstand the procedure, and if they explode, that usually means that they were already done. Now, it is a little hot, but even if you cover them, they're still going to be exposed to high temperature. There's no way around that, because the board is going to be heated up to 200 degrees from the bottom. So there's no way to protect the cups. Now, if you use hot air and you're blowing with hot air, Like on ECMs, we normally put the aluminum foil on the electrolytic cups to protect them, but the board never heats up to high temperatures. In this case, the whole board is going to be hot, so all of these cups, even if you cover them at the top, all of these cups are going to be exposed to 200 degrees Celsius. There's no way around that. You know, they're going to be heated up from the terminals, right, from the bottom. And when the board is hot, I can just take the tweezers and I can lift any any electrolytic cup over here, just heating from the bottom. So yeah, I know. No one complained in my last video when the cups exploded, because they normally don't. That happened the first time in a long time, and on the old board, right? So I was surprised that no one corrected me, like, oh, Raf, it exploded because you didn't cover the cups. But again, even if you cover them, they are exposed to the same temperature. You might catch a degree or a couple degrees because the heater at the top is not going to be radiating directly onto them, but you're still above 105 degrees, right? They shouldn't work over in temperatures over 105 degrees. But that's when they're operating, right? When we do this, there's no electricity going through them, so it should be fine as long as they keep stay sealed. It's good. They are designed to allow a little bit of pressure to build up in them. It's just when they're old, they tend to explode. But I don't expect any of these to explode on this. As I said, it's very rare that any cup explodes. But it's the risk. It's the risk we have to take. And if they explode, we'll see. I'll probably replace them if they do explode. Although it's a major pain, and especially on this board, because there's plenty of tiny components on the left over here, on the left to the CPU. So if you cover this with anything, you risk that you'll move the cover or something, even if you use Kapton tape or whatever. You risk that you're going to move some components, and it's even worse. It's easier to replace the cup than figure out which component has been knocked off. And again, you're still exposing them to too high temperatures. There's just no way around that. I mean, the only way around that would be to just remove all of the electrolytic cups and then replace the socket and then replace the cups, or just preemptively recap the entire board. That's also an option, but we can do that in the budget of $55. So there are some risks we take, but we're still at roughly 80%. Actually, lately, I'm hoping that we increase the success rate. I just had an email from the customer from a couple weeks ago, maybe, or a week ago. The board wouldn't post, and then a few hours later, the customer wrote that it did post it, and it's working fine. Because he was asking, like, can we like reflow the socket perhaps or something like that. But I don't think we have any issues with soldering anymore. We resolved the problem of warping the board by long preheating. We solved the problem of alignment. Well, that was a pretty crucial problem to solve, but the only way to solve it is to just learn how to align them. That's how I solved the problem. I had to mess up many sockets before I learned how to align them. And the third, the actual soldering. So the flux, type of flux, how we apply the flux, wicking, all that kind of stuff. So all of these problems were eventually solved. So now the only remaining potential problem is, either the board just didn't like the heat, it warped maybe a little too much, some trays got broken or damaged or whatever. Maybe exploding cups, rare, but it does happen. Other than that, turns out some boards, because I had another customer a few weeks back a local guy. He picked up. He sent the board because he didn't know I lived so close, but he picked it up himself. And also he called me that the board doesn't post, and then another call that they did post. It was a memory problem. I think memory stick was had some problem or something like that. That is also why I don't provide any testing, because for different boards you need different memory, and I'm not only talking about the DDR3, 4, 5, but also different speed that the motherboard will allow. And you have cases where, if you put too fast of a memory on the board that doesn't support it, and it might not work or might not be stable, might not post, or might post but won't boot to Windows and that kind of stuff. Now, yes, it is a CPU that talks to the memory, so the CPU must support the memory, but CPU talks to the memory using the connections on the motherboard, right? So if the motherboard itself doesn't support these speeds, then even though the CPU supports the memory, it won't work. And that was the problem in this customer's case. Also, I noticed that in some cases, since I removed the battery for the procedure, and then I sent the board with the battery just kind of stuck to the board, right? It's not replaced, because I want to leave it for a little while for drying and stuff. Once you replace the battery and boot the board, in some cases that process takes a little while. So it seems like it's not booting, it seems like it's not posting, but give it a little more time and it posts. I've seen that as well. But that is my whole point of not testing, to actually comprehensively test the board after, or any board. You literally need stacks of equipment and parts and stuff. Memory is crazy expensive right now, and actually all the electronics nowadays are pretty expensive because AI took all the hardware from us. Let's hope it's putting it to good use, but I'm not too convinced. So this would be a very expensive endeavor on my part, just to collect the hardware that I would need to test like pretty much every board. And we work on 1851s, AM5s, 1700s, 1151s, 1200s. So that's 5 CPUs already, just different kinds. And now you need at least 2 of each kind, if not 3 or 4, because some boards will support these gens, other boards will support those gens. The BIOS might not be, might not allow this particular gen of the CPU to work, or the board just doesn't support this generation. That's it. The same with memory. So we need DDR, well, maybe not 3, because nobody does DDR3 boards anymore, but DDR4 and 5, right? 2 kinds. And then from each kind, you need at least 2 or 3 types when it comes to speed and stuff like that. ECC, non-ECC, or, what have you. So just imagine how much hardware to begin with you have to collect to do comprehensive testing, and then testing itself. So we replace the socket, the board doesn't post, but we detect that we have a short on vCore, or the PCH is not turning on, we have missing voltage, or that kind of stuff. Now, did it happen during the procedure, after the procedure, during shipping? We don't know. So now what do you do in that case, right? The board doesn't work, but I'm convinced that the socket is soldered on correctly, right? There's no there's no problem with the socket, but the board doesn't post. Now, in other cases, customers are free to send any board. It doesn't have to work. So, perhaps you get the broken board on eBay that has one missing pin or bent pins, right? It's maybe not as common nowadays, but it was very common for broken boards, right? Boards that wouldn't work. Say the PCH was faulty, or EC. problem, or some voltage problem, but voltage problems are typically easy to repair. But if you have EC problem, you have to source another EC. It needs to be programmed. I know sometimes it's a BIOS issue, although these are also usually easy to repair. But what the sellers would do is when the board has a very complex problem and you can't fix it, but you're not going to sell it with that complex problem, right? So what they would do is just take tweezers and just bend 2 or 3 pins slightly, right? Then take a good picture of the socket showing that the pins are just slightly bent, and you can find a willing customer to try and repair that, because bending the pins, that is not that hard as long as none of them are actually broken off. You know, you correct the position of the pins, and the board works. And this computer that I'm using right now is exactly that. I bought the board with bent pins. I got the pins straight, and it's been working for 3 years now, if not longer. So it does happen, but there's also a lot of tricks like that that the sellers might do, and they sell you a board that you expect only problem is few bent pins, but there's actually some other problem. So if you send a board like that to me, then you know I replace the socket, and the board doesn't post. Does it not post because of the socket, or something else was wrong? So it's a black hole. It would have to take a lot of money for any technician to just take the board for the socket replacement and guarantee that the board works afterwards. And there were companies that were offering that on eBay. There was one shop in Massachusetts, there was one in California, and they no longer provide this service. But the way they priced it is you pay $80, you send the board, then they assess and give you the actual quote. So on top of that $80, you get a quote for this is what it's going to take to fix it. So if the quote is for $200 plus $80, so you have nearly $300 for the procedure. Well, with that budget, sure, you can spend even a couple days, if not longer, trying to diagnose and repair the board. But first of all, you need to be kind of specialized in motherboards. So whenever people ask me about actual fixing, you know, sometimes I take it for a bench fee, and you know, let me connect it, let me send it with the CPU and memory. Yes, you have to have a lot of trust that I'm not gonna steal your CPU or memory, right? Nowadays, it would probably be profitable to steal memory from people, but I don't want that kind of profit. So if you send it with CPU and memory, I'll take a look and let me see what I can find out. But usually I just, you know, redirect customers to either Motherboard Medic, because he specializes in actual motherboards like this. So it's a lot easier for him to, you know, to run quick diagnosis. He can do it cheaper and quicker because he does only that. That's the power of specializing in something, right? He also has tools and stuff. I'll have to make a tool for measuring current. But even if I do, then you know I don't know what kind of current the board should take, right? So that only comes after a while when you specialize in something, right? If I grab an ECM, I know how much power it should be consuming because I work on a lot of these. On the motherboard, I don't know. I mean, I could find out, and you know that would be a learning process as well. But essentially, you know, I don't have proper tools and proper know-how to quickly diagnose the board and to know where the problem is. And you know, sure, I can replace the EC or that kind of stuff, but again, there's going to be nuances, right? Will the EC program itself from the BIOS, or will the BIOS program EC? Or do you have to program EC? If so, then you need to have a programmer for those EC chips, and you might need some couple adapters and all kinds of stuff. Also know where to get the binary from and that kind of stuff. So it's not as simple. That's why this service is just, I remove this socket and I place new socket. And I don't give any guarantees, but at least you see how the process went, and you know exactly if something went wrong, like maybe you board popcorned or bent, or you know if something went wrong essentially, then you know you can at least know what went wrong and why. So it's not a black box. You don't have to worry about did the technician even look at my board, or did they just charge me $55 and never even tried and just said that, well, it didn't work, right? We'll have a board that I need to get to replace the memory slot that is broken. And someone is also sending one to replace the power connector. This one's actually pretty easy, so that's not very expensive, but still requires a lot of heat, a lot of patience. PCI Express ports or slots, right? That kind of stuff that I can do, right? No problem. But when it comes to actual diagnostics of these boards, and then actual, guaranteeing repair, that's not something that I can offer. But I can sure try. If you get $50 for a bench fee, send it in. Let me take a look, see what I can do for you. And if I cannot do it, I can at least recommend someone who can. So in either case, you're gonna have your board fixed. Oh, looks like this is the first board that is not warped at all. Yeah, it's perfectly straight. That's good. Alrighty, let's fix the profile in Rework Pro, and let's speed up the footage, listen to some music, and well, unless something goes wrong, I'll see you guys afterwards. Otherwise, I will see you guys in the next one. Thank you very much for watching. Take care.